Welcome to Scale AI and our presentation on AI and how it's revolutionizing productivity for the frontline worker. I'm super excited today. We've got a phenomenal guest with us. Before I introduce him, however, I want to remind everyone that after this presentation, we'll be doing a product demo on Scale Rapid, and we'll also have some virtual one-on-one networking on the agenda tab. So again, thanks for being here. I am Mark Valentine. I lead the government team here at Scale AI. And I'm very fired up. I've got a close personal friend, as well as an incredibly special guest named Dave Marra. Dave Marra is the general manager of artificial intelligence and mixed reality at Microsoft. And he has spent the last 10 years of his life trying to make people more effective and more efficient at what they do in numerous contexts by connecting them to their data and using devices to connect those data to the context that they're working in. So I had the honor of meeting Dave about 10 years ago when he was bringing the Microsoft HoloLens to life, and he trusted me enough to actually let me carry it around, which was really cool. And he continued working in that area, and I was able to work with him as well at Microsoft as he led Microsoft's efforts on the US Army program that is known as the Integrated Visual Augmentation System, or IVAS. So Dave, welcome to the stage.
Thank you, Mark, and thank you all for having me in today. Just being here at the Scale HQ is an awesome experience. This place is just brimming with innovation and intelligence, and you can feel it walking through the hall. So thanks. I'm thrilled to be here and talk about all of it today.
Awesome. And I'm really excited to have you here. And I'd like to get started, Dave. You and I have talked about your history before. We go way back. But you weren't fully formed, as a titan in the AI and the mixed reality or augmented reality.
I'm not sure I'm still fully formed, but we'll
No, you're a titan.
But
we know that you didn't start life fully formed there, right? And you and I have talked a lot about your past and your history in this tech space. So I was hoping you could share that with the audience, because not only is it instructive and kind of give a background of how you came to where you are, but I think also gives a bit of a primer on the technology itself and how it has changed over time. And where it fits into this broader ecosystem and how it solves human needs.
Yeah, sure. I think as technologists, we often get so caught up in the if P then Q of life, of the week or the quarter or the month, that we often forget the whole journey that we've been on. And so it's really helpful to zoom out. In fact, I was doing just that a couple of days ago as we were thinking about today and what we would talk about. I actually started out serendipitously in the video surveillance industry. And this was at the time when video surveillance cameras were hardwired to analog video recorders, coax cable, analog video recorders. And there was this
VHS or beta?
Both, depending on the country and the customer. It was at this time when there was a huge transformation moving from analog video to digital video. Right. And we built a software tool to aggregate that video that video data, analyze it. At the time, we were using some computer vision techniques, and loosely the industry referred to this as analytics. Right. And it was like, hey, I've got a camera over an ingress, and I want to get a notification on somebody egressing from the ingress. Yeah. This helps kind of notify people that are in the secure enterprise of what's going on. We had some success with that business, and before too long, we were managing enterprises with 10, 20, 30,000 different data sources, cameras coming into this thing. So when you think about that and think about how we were in the early ages of computer vision then, 20 some odd years ago, and what we were doing for the secure enterprise then, it's quite astounding. Just doing basic computer vision techniques on video surveillance data. Before too long, we had end users, like I said, with thousands of video sources, aggregating that data, comparing it to data sources from other sensor sets and arrays of data, et cetera, to surface information of interest or actionable information to the end user. That led me to thinking about the entire paradigm of user and computer interaction, specifically the human interacting valuably, efficiently with data. At that time, of course, the entire computing paradigm was built on a metaphor that I had an acronym for, and much of us in the user experience space at that time had an acronym for, called WIMPY. Windows, icons, menus, and pointers. And for the last 50 years of tech, That is how people have primarily interacted with data graphical user interface. So that led me to my next venture, which was working on technologies to increase the efficiency and the elegance with which humans and computers interacted with data. And I was focused on two things. One, and at the time, 15, 18 years ago, touch as a unique paradigm or a discrete input paradigm was wholly unique. None of the core operating systems at that time had an input paradigm for touch or ink. And so we started to write hardware accelerated interfaces that allowed you to use click and keyboard and touch and ink to interact with the data.
So a diversity of inputs.
Diversity of input to make it more elegant. And so at that point, just continuing this under-threading of how artificial intelligence has revolutionized the human-computer interaction, we take it for granted. At table stakes, everybody grabs some device and they immediately go to a picture and do this number to do it. But in 2005 and 2006, teaching a computer with a wholly new discrete input paradigm how to recognize two particular blobs and then move them in opposite vectors from each other and then translate that into an input action in a UI was wholly new. And it required some significant AI and some significant low latency kind of implementation of that AI to get the user experience to where it needed to be. And so we worked on that for quite a bit in 2006, 7, and 8. And immediately I began thinking about the next iteration of using heads-up, hands-free, augmented reality displays as another paradigm of computing, essentially mixing digital life and analog life in a mixed reality environment. And that's what led me to Microsoft and to join the then cloaked team at Microsoft working on mixed reality tech and specifically our commercial products that we have in the market today, HoloLens.
Awesome. And can you share a little bit about like how the commercial tech and HoloLens was integrated into this broader program you're doing with the U.S. Army?
Yeah, you just think about the level of intelligence that you have to teach or give the computer or bestow upon the computer to have an elegant mixed reality experience. The device needs to understand where it is in space.
Right.
And so immediately you're running not only SLAM, but computer vision to try and understand and orient itself into space and to understand the surface of this chair, the surface of this floor, et cetera, to be able to render holograms that are world locked and make sense to the user. As I change my perspective on you, the analog Mark needs to respond the same way that the digital hologram or avatar of Mark responds. And that tech is far reaching. In fact, the reason that AI and mixed reality are so closely coupled together at Microsoft and really any field where human computer interaction is pushing the envelope of normal paradigms is because you're having to teach the computer how to understand you and teach the computer how to understand the real world. And you have to do that at incredibly high speeds and an incredibly elegant manifestation so the experience is natural for the user.
Yeah, it totally makes sense. And I appreciate you saying that because, you know, when you use the words artificial intelligence and then you apply it to mixed reality, I'm not sure that connection is as intuitive to everyone that might be in the audience. So I appreciate you covering why these two things are related and help us connect the dots there. So I do want to take one quick step back. We used a term, we said mixed reality. And I know a lot of people talk about virtual reality. A lot of people talk about augmented reality. And I remember when I was at Microsoft, we used to talk about it as a continuum. So I was hoping you could share real quickly just some definitional concepts around what is VR, what is mixed reality, and what is augmented reality.
Sure. The way I think about it is quite simply, as you put it, mixed reality is a continuum of experiences, where on one end of this continuum or spectrum, you have a virtual reality experience. And that's usually typified by a headset that is completely opaque. And everything that you're seeing is being synthetically generated, whether that's a computer generated image or the video from a pass-through camera. That is typically a virtual reality experience. On the opposite side of that spectrum, you have something where you're optimizing for the user being able to perceive the analog world, and then you're imputing or imparting digital content into the real world.
So this would have been my old heads-up display.
This is your whole heads-up display that helped you do all the awesome things that you did in that machine.
That's right.
So yeah, augmented reality, virtual reality. The spectrum is mixed reality. There's no right or wrong, better or worse. It's all situation dependent as to what is the right experience for the right application.
Okay.
The most elegant approach is to have a device that's capable of doing both equally well. We're still a little bit short of that tech, but certainly when I think about the way the ball is going, that's the way that we want to be.
Got it. And so just so I'm clear, and I want the audience to be clear, we've got these two poles of this, AR on one side, VR on the other. Is mixed reality just somewhere in between?
Mixed reality is the entire continuum.
Okay.
Mixed reality describes the entire continuum of experiences that are enabled. Let's say that I want to put myself courtside at a basketball game, but from my couch. The best way to do that is through a really high resolution virtual reality experience. The opposite kind of experience on the opposite side of the spectrum is I'm working on a complicated machine.
Yeah.
I need my hands and my head up and free to do things on the machine, but I want the computer to show me where to put the wrench and where to put the tool to go do the thing. So preserving my analog vision while I'm augmenting it with digital instruction or data.
Got it.
Yeah.
Excellent. So thank you. So I think we're focusing on some of the tech now, and we talked a little bit about where AI falls into the spectrum, how it enables some of these things. What technology barriers are you seeing in this space that is, let's say, affecting adoption, preventing us from more widely adopting these types of technology?
The way that I think about it are, what are the technical enablers that are going to continue to push the capabilities of the experience or deepen and broaden the envelope? And there's a list of them.
Okay.
Certainly AI is among them.
Right.
The more that the computer that you might be wearing on your face can understand the real world, the better.
Right.
And typically a lightweight, comfortable face-mounted computer is not going to accommodate some sophisticated LiDAR.
Right.
So using AI to be able to understand the world through pixels is a enabling function that will continue to progress the use of mixed reality. So that's just one, like we're just starting from the pipeline of the computer, and I'm saying that in a very loose term. The device that you're using, being able to understand where it is in the world and what is in doing. That's one example, understanding the world through pixels, through computer vision techniques. Second is, of course, in a truly augmented reality type scenario, preserving the ability to see the analog world is to make super high resolution displays that are clear, which is a challenge. I understand you might have taken some physics in your career. Yes. The speed of light is involved, and it is often an inhibitor to how well you can do it.
That's right.
So yeah, the strategies for most of these devices are reliant on optical waveguides as some sort of light source that is injecting photons in the waveguide, and the photons are bouncing back and forth in the waveguide at a very fast rate, and then they're exiting the waveguide in accordance to the way the waveguide was designed, and then forming imagery on the back of your eye. So that's another category of advancement. And where modeling, I don't know if you've ever tried to measure the speed of a photon, but it's tough. It's very tough. And this is something that an AI on a computer can do much better than you or I with slide rules and other antiquated techniques that we learned math on.
Well, and it sounds uber complicated too, to the point where a device with that much technology in it probably works well in a lab, but when you get it out in the real world with, let's say, humidity and shock and water, something that has to negatively affect it.
It does play a part in it. So you think about, like, okay, now I've got to have this computer, and it's passively cooled, and it's not like it's sitting on some heat sink. It's sitting on your face. It can't get tremendously hot. It's got to understand the world outside of it, and those are fairly computationally intensive activities. And it's, oh my goodness, did I not put my phone on silent?
You owe a drink at the bar later.
I thought for sure that I had put it on do not disturb. Sorry about that.
No worries.
It's got to understand the real world through cameras, and accelerometers
Right.
and IMUs, and that's a computationally intensive task.
Yeah.
It's got to do that while staying cool and running off of a battery. Then you have to have some light source bouncing in photons in acrylics, and those are fragile and large. And then you got to compute all of the things from the photon into the sensor that's understanding where it is, to understanding your relative position through visual techniques and inertial techniques, and then compute fast enough so that when I move my head to the right or to the left, my perspective to the holographic whatever is rendered appropriately when I expect it, or better yet, when my inner ear expects it to happen. And so doing that pipeline and conducting that whole orchestra in a very short period of time, which is about 5 or 8 milliseconds, because if you exceed that, you start making people very uncomfortable. To use eloquent language.
Absolutely. Yes. I want to take a pause here, because when I listen to you describe this, and by the way, I've worn these devices that you've worked with on my own head and witnessed it personally, there's almost an Arthur C. Clarke level of magic that's happening here, right? Because the complexity of what you're describing is absolutely amazing to me, that we're able to squeeze that into essentially a personal computer that you wear on your face that, quite frankly, is a commercial item.
That's right. And that's what I think. It's something I think earlier about, like, zooming out and thinking about it. And I think about how in 2006 and 2005, converting a 2-finger gesture to expand on a picture or a map was wholly novel. And now we're doing it with articulated hand tracking, another element of sophisticated computer vision, on digital data that is oriented in XYZ space appropriately.
Wow.
And we're doing it on a timeline that is fast enough to simulate the real world to an extent that it doesn't make you want to vomit.
It doesn't make your vestibular system go crazy.
This is correct. Yeah, this is correct. So doing all of that, and then I think to your point, getting it miniaturized to a point where the human head it's comfortable to wear.
That's right.
And then further, as we get into like the IVAS program with the Army, I'm never one to not make my life difficult. And so we started with the single hardest frontline worker in the soldier, the person who has to run and shoot and move in the rain and in the hot and in the cold and in the sun and in the dark. Getting all of that stuff to work, small enough and comfortable enough to wear, doing vigorous activities, and rugged enough to withstand the environments that it's got to operate on, has been no small feat. And so for the tech industry writ large to have come that far in just the last 10 years is staggering.
Well, I was amazed at the speed at which the IVAS program happened, where it went from here's an interesting white paper of a capability that we may or may not be able to do, to here's a prototype, to now people are actually using it, and iterating on it.
We are shipping thousands of systems to the U.S. Army currently.
That's amazing.
And 4.5 years. It's amazing.
Absolutely mind-boggling to me. And I want to get back to that in just a minute. But I want to take a step back. You talked about a device that is comfortable enough to wear for long. I agree with you. I think that is a huge technical barrier to wider adoption. And my experience from flying fighter airplanes in the Air Force, we had great sensors and we had these great night vision goggles, but personally wearing that on your cranium for hours and hours and hours over several years, I mean, I'm literally missing 3 discs in my neck because of the strain that caused. So
evolution did a really good job as making our neck and spinal cord strong enough to support our brain.
That's right.
It wasn't contemplating anything else at that point.
Especially putting some night vision goggles on a moment arm that pulls your head down.
That's right.
Awesome. All right. So I don't want to dig too much deeper into the pure tech side of it because I know we're limited on time. But I want to go back to this adoption thing. And we talked about IVAS, and I want to get there. But whenever people talk about augmented reality, I always hear this term come up, and it's the Metaverse. So let's help our audience out. What is the Metaverse? When are we going to get there? And what are these interim steps?
You are going to force me to be yet another in a very long list of people giving a definition of the Metaverse. I'm happy to do it.
I'm not going to hold you to it.
Okay. I think about the Metaverse 2 ways. I think about it in practice, and then I think about it philosophically.
Okay.
In practice, and my 8-year-old Louis at 6:20 Eastern is probably playing Roblox right now.
Yeah.
He is in a world where he is socializing with his friends.
Okay.
He is communicating and playing a really, really fun game.
Yep.
He's able to buy stuff in Roblox. He's able to do fun things. He's able to learn things, and he's able to hang out with his friends. So in practice, Roblox is a canonical example of the metaverse in action today. And I think everybody's familiar with that metaphor. Certainly, it's not novel. In principle and philosophically, what I think about the metaverse is truly the convergence of humanity in an immersive digital environment. And that's typified largely by a completely immersive experience through a virtual reality kind of construct. And that's what I think about the metaverse. And I think that is certainly, I'm certain that the evolution of the internet is three-dimensional, immersive, collaborative space, whether that's for work or play or learning, et cetera. And that's how I think about the metaverse. And I think we see it today in experiences like Roblox and many, many others in the entertainment and education
For my
space.
son, it was Fortnite.
Fortnite,
he went through that phase.
That's exactly right. And these are things that didn't set out to be metaverses. It just turned out that the ecosystem worked out so beautifully as to create this experience. And then I think about it in 5 to 10 years about an immersive place where you and I might have this exact conversation in a completely digital or synthetic world. You are sitting in the comfort of your home in wherever, and I'm doing the same thing in my home wherever. I think that
in one of these worlds, could I be on Mars or something? Is that
you could certainly be on Mars? And these experiences are really great for talk about democratizing incredible experiences that are usually only reserved for the 1/10 of the 1%. Not everybody can visit Richard Branson's private island in real life. However, a highly immersive, high fidelity metaverse experience can put that experience as well as sitting, and watching Leo Messi play soccer, on the pitch. And that can happen in those types of experiences. So it's I'm enthusiastic about the future of that experience.
Yeah. Well, I appreciate that answer, because I think in most people's mind, when they think quote unquote metaverse, they're going to that latter part that you described, right? This completely immersive experience. But in many ways, we are already living in perhaps little mini metaverses, whether it's Roblox, Fortnite, or even online poker. Some might say could be a metaverse of some sort. So maybe we're not at a complete digital immersive experience yet. But I want to get back to the MR technology where it is today, because I think there are amazing areas where it can make humans more effective at what they do. And you described a little bit about the Integrated Visual Augmentation System program, the IVAS program, and I think that is super cool, because people see that and they go, wow, this is a futuristic set of mixed reality goggles that a soldier is wearing, and it's making them more effective and efficient in training and in combat. It's super futuristic, super cool, and quite frankly, super sexy. But I can think of maybe 100 areas that might not seem as super futuristic and sexy, but where AI and mixed reality technology can have a real impact, like today. And so I was hoping you could share maybe some of your thoughts around that.
I'm incredibly passionate about the ability for, mixed reality and AI are so intrinsically linked that it's really one thing. So let's just say an intelligent end user device that understands the real world and allows the end user to be heads up and hands free and do what they do. Just stepping back, and when we think about the world of people who do things in the world, a billion or two of us are knowledge workers, guys like you and me now, that send email and have Zoom calls and look at PowerPoints and things like that.
Take dull pencils and stick them in our eyes.
This is true. There's 2 billion people on this planet that actually do real things with tools. And that's everybody from a brain surgeon to a soldier, to somebody who's fixing the helicopter, to somebody who's fixing the airplane that I traveled on here today.
That's right.
To the person who's picking and packing in an Amazon fulfillment facility. And that segment of the world, while the tooling is functional tools, hand tools and machines, quite sophisticated, big tech from a productivity standpoint
Right.
has yet to really revolutionize or transform that frontline worker segment. And so I'm passionate about leveraging these intelligent end user devices. That is the kind of terminology that we might coin here today, which is, you know, a combination of an
intelligent end user.
Sure. It's a metaphor for this inextricable link of mixed reality and artificial intelligence to a comfortable, and comfortable is subjective.
Yeah.
You know, and you have a bang for buck kind of return on investment on how much discomfort are you willing to tolerate in order for value in terms of experience, value of experience, and the impact of what the computer is doing for you.
Right.
An incredible future as far as those intelligent end user devices revolutionizing the way that people do work. When I think about the defense segment specifically, IVAS services the close combat force. That is the infantry.
Right.
There's about 100,000 of those people in total in the US. That is less than 1/10 of the actual uniformed force just in the Army.
Right.
And so when you think about that, that's one soldier, one person with boots on the ground and a rifle, with 10 people behind them supporting them from a logistics standpoint, from a maintenance standpoint, from a training standpoint, et cetera. And so thinking about how we can leverage these underlying solutions for those end users to make them more effective is where I think we really get massive needle moving kind of impact. And so I'm thinking a lot about how we take a comfortable, intelligent, rugged device. And Mark, you and I have been talking about this for 10 years. This is not novel for you and I. We have, how much time did we spend at RightPad or Warner Robins talking to folks about how to revolutionize flight line maintenance, et cetera, through augmented reality.
And we're going to do it someday.
We've
got to do it.
We thought we were, we are so close.
Yeah.
And IVAS is one of those change agents and forcing functions for the ruggedization and miniaturization and overall empowering kind of agents for this technology that democratizes the capability for the rest of the force and then the entire frontline worker segment of the world, which is billions of people. And that's what I'm quite excited about.
Well, it's interesting you put it that way. And you know, when I tie it back to Microsoft's mission, and I thought Satya did a great job organizing around this mission, you know, allowing every person and organization to achieve more. I think that's exactly what you're doing with the IVAS program and with the mixed reality program in general. And I 100% fundamentally believe you're on the right track, enabling quote unquote frontline workers, because I do believe many of them have been ignored by tech because we assume that everyone sits at a desk and shuffles around emails all day, and that's what knowledge workers do. And I will share a story real quick. You know, when I was in the Air Force, I didn't even know we had a chief information officer in the U.S. Air Force until I was like a lieutenant colonel, because that person had no bearing on my ability to accomplish my mission in the F-16, right? So bringing those tech capabilities to the actual warfighters or the frontline workers who are working on the airplanes, I think is absolutely a game changer. And if there's anything Mark Valentine in person or in particular can do it, or we at Scale can do to help you do it, you got my promise that we're all in.
Well, I know that it's the people here and the people who are using this tech in order to accelerate the capability of the intelligent machine or AI, and whether it's a supervised learning agent or something more sophisticated than that.
Absolutely.
The need to get the intelligent end user device to better understand the world and better understand what the human is actually doing at that particular point in time are the key accelerants to making these experiences hyper valuable. So whether you're doing something relatively mundane or whether you're doing something very sophisticated, like fixing the jet on the F-16 or something.
It's not mundane when you're flying the thing.
It's not mundane at all when you're flying the thing. I'm certainly not. You've got you've got people throughout the frontline worker community, whether that's a sailor on a nuclear submarine working on a reactor,
right,
or whether that's the person who's fixing the elevator in a high rise, that can be largely enabled and empowered to do their job better and safer with a purpose-built productivity solution.
Absolutely.
And that's what I continue to think
so
about.
here's a use case idea for you. Write this one down. You put my name on it. So AAA, you know, the organization that will come help you, you know, when your car runs out of gas or you need to change a tire. What we do is we have all these kiosks with a HoloLens or a similar device. When your car breaks down, you grab it off and somebody walks you through the repair. Fix your own car. That's AAA of the future.
This is
who's with me?
This is an angle. This is an angle. This is a definite angle for sure. I know you're being coy, but you think about it's actually the things that you can't think about that are the most compelling. It's like you put this platform out there and you democratize it in terms of being able to service a vast percentage of the population, face sizes and shapes and disabilities and various things. And you let the community of practitioners work on it. I don't think that you and I can contemplate all of the amazing things that the tech is going to be able to do. And that is a direct result. Again, I keep coming back to this thing like a mantra. It's getting that solution, that end user device, to be able to understand the world and understand the human better. And we do that certainly by a sensor suite that's looking at the real world, and by a sensor suite that's looking at the human. And we're thinking about things like sophisticated eye tracking systems that are looking at the saccades of the iris and deducing the health and status of the human that's actually wearing the device and perhaps their intent. We do that by electroencephalography, thinking about what the actual person is thinking about. So imagine when we think about, since 1972, the environment of computing has been that wimpy metaphor, windows, icons, menus, and pointers, and then moving it to something that is based on your thinking your way through the computer. And the way that you interact with digital data is the same way that you act in the analog world. And so the acronym that I thought about that was COGIT: containers, objects, gestures, elements, and natural things. And so the more we can,
writing that one down,
the more intelligence we add to the end user device through AI and machine learning specifically, the faster we're going to accelerate the value of the thing, which is to make the human more productive in what they're doing.
So a few minutes ago, we talked about like technical barriers to adoption. And last night at dinner, you and I were talking about non-technical barriers to adoptions of various technologies. And I find it really instructive. You and I were talking about video calling. And video calling has been around for decades, but it really wasn't widely adopted until we had a worldwide pandemic. And all of a sudden, people jumped on board. So what are some of the non-technical barriers you're seeing to the, say, broader adoption of AR, MR technology?
I think about the adoption curve in a lot of different ways. Many of them are just experience related, which can be rooted in two things: technical and societal. And having a socially acceptable device that you're wearing throughout the majority of your day, that's obviously comfortable enough to wear throughout the majority of the day, and then one that introduces a collaboration or a communication experience that is acceptable. And you can see it now as we are gentlemen of a certain age. We're looking at the younger generation and how it's a mostly text world, and how there's these nuanced kind of levels of communication, whether you're using a Slack chat or a Teams chat, and then a text, and then a text or a group text versus a phone call versus a video call. And so society is going to grow into this new paradigm of interaction where perhaps a lot of meetings are completely synthetic, and where I'm rendering myself as an avatar. And so I think that the evolution driving the adoption of that tech. When we think about, again, back to the consumer and commercial metaverse, is going to be societal change. And then obviously the rest of it is really contingent upon building a hyper natural experience with a hyper comfortable device.
Right.
And so technical and societal are kind of the factors that I would bucket the things to think about when I think about the evolution and adoption of this tech.
Well, and I would imagine in the societal area that you're talking about, just general trust and privacy and some of the things we talk about in the normal computing environments are going to play a major role in that.
Of course. Of course.
Interesting. All right. So this has been awesome, but I do want to stare out into the future a little bit. You being an expert in this space, you said earlier, probably the most interesting things we haven't even thought of yet. So let's look at a couple of areas. Help me glimpse the future. Do you see the adoption of this technology in entertainment, in education, healthcare? Where do you see at least like the most traction for future adoption of these technologies?
I think that intelligent wearable devices, mixed reality with significant AI, is the third paradigm in personal computing, where we had desktop computers, and now everybody's got 100x that compute capability in our pocket, or in this case, ringing in the middle of our discussion today. I apologize for that. And then third, some wearable device. So I think that the entire world will adopt this technology soon. When I think about what markets or segments are going to grow the fastest, I'm 100% convicted that the frontline worker represents the nearest term fastest growth. In fact, I believe that there'll be some compound annual growth rate of adoption in the maintenance frontline worker category writ large of 40 or 50% between now and 2030. And Mark Zuckerberg is not wrong. And Microsoft is not wrong. And Google and Apple are not wrong about the commercial and the consumer metaverse and commercial and consumer devices and socially acceptable glasses that we're going to walk through the world with and get help, shopping and navigating and seeing people and all of that. I think between now and the end of this decade, I think you're going to see the vast majority of transformation in the frontline worker segment. And that's, you kind of decompose that into the spectrum that I talked about for surgeons or automotive mechanics,
there's the healthcare
factory workers, or et cetera, et cetera, et cetera. There's, in each one of those categories, there's significant headwinds. I wouldn't say headwinds, it's a bad metaphor, but challenges. Certainly in a healthcare environment, you've got to make sure that those things are doing it exactly right when somebody's on an operating table.
If you're going to open me up, I like low latency, high accuracy.
Comfort and integration with PPE that a surgeon or another clinician is wearing in that particular environment. I think certainly very interesting to think about note taking when the clinician is with the patient. As I understand, and as I've talked to a bunch of doctors in my life, the best experience is when I have with a doctor, or when the doctor's like looking at me and talking and we're having a natural conversation versus looking at my chart and doing this number. And so again, the computer's ability to understand the real world and the subject matter and elegantly integrate into the experience and into the interface between humans is the most powerful thing. So in that scenario of healthcare, can I use a mixed reality solution in order to fundamentally transform the doctor-patient exchange? Capture notes, input it into the electronic medical records tool, make that queryable and searchable, actionable with an AI looking at the record and understanding what happened on the past 3 visits, and then surfacing to the doctor, perhaps in near real time while I'm having that conversation, that this is another question I should ask, or this is another thing that I should be investigating. So healthcare, and then I come back to the maintenance worker, the person who's maintaining a sophisticated thing. The DoD has a significant problem. The last 20 years, we've been engaged in a war with a different kind of an enemy.
Yeah.
And that kind of an enemy isn't an enemy that you engage with big aircraft and aircraft carriers and things like that. However, the world has, and we're seeing it right now in the Ukraine,
Indeed,
now a legitimate threat of a near peer or peer level adversarial conflict. And that means that we have to make sure that all of our aircraft are up to snuff and all of our aircraft carriers are working right and our shipyards are really productive. And the DoD has this aging NCO corps,
right?
And that tribal knowledge is evaporating by the year. And how do we get the young airman, the young sailor, the young Marine,
right,
the young soldier up to snuff on how to go do the complicated repair?
I think you're 100% right. And when I look at real elements of national power, obviously the combat power that the United States military can put forward is unmatched. But the real engine behind that power is the logistics capability of keeping it running. And I think we're seeing a really interesting analogy in the Russia-Ukraine conflict, where the Russians don't, or it appears that they do not have that capability. And we're seeing what results from that. So I think that's amazing. And thank you for the glimpse of the future. I think we're about to run out of time, but I can't let you get out of here without going through the rapid fire round.
All right, rapid fire.
So,
rapid fire me.
That's right. So you work in the AI space.
I do.
Right? So I know that you're an expert at harnessing the predictive capabilities of artificial intelligence. And so there are a couple of questions that I have, and these are questions that the world really wants to know.
Yeah.
So we'll go through them real quick. What are next week's winning Powerball numbers?
The best.
Okay, we're not gonna share that one.
All right.
We'll talk later about that one. All right. Will generative AI ever make a song cool enough to compete with AC/DC?
I believe that it will. In our lifetime.
Wow.
Mm-hmm.
Really?
Mm-hmm.
Like Hell's Bells, Back in Black, that level?
I believe that it will. Yes.
Okay. Wow. Shocking. All right. What month and year will humans colonize Mars?
Oh. I want to think about this.
We'll let you call Elon if you need to.
I'm not going to call Elon. I'm going to think about it. I think that it's July 2027.
All right, July 27. I've got it written down. I'll call you then, and we'll see how it goes.
It's ambitious, but that's if it's
around
worth
here
doing,
scale,
it's worth overdoing.
We say ambition shapes reality.
Sure.
All right, so here's another one. This was really important. Who's your favorite AI company?
Scale AI, for sure.
Excellent. Well done.
Yeah.
All right, and this final one, this is super important.
So leading and so easy of me. Yes.
This one's super important to me, and I know many of our watchers here.
Sure.
Very, very tough question. Will Alabama make this year's college football playoffs?
It's decidedly undecided. I'm sorry to tell you. I saw the way they played last week. It was an interesting game. Yeah.
All right, that hurts a little bit, but I'll take it. Truth sometimes hurts, but you have to listen to it. Dave, thanks so much, man. This was an incredible session, an incredible discussion. I personally learned a lot, and I know that our audience did as well. Before we let you all go, I want to remind everyone that after this session, we will have a product demo of Scale Rapid and an opportunity to do some virtual one-on-ones in our networking, virtual networking area. So go to the agenda tab for that. So again, before we go, I just want to remind everyone, we are actually broadcasting today. It's the 10th of November. And that means that I'd be very remiss, even though I am a retiree of the United States Air Force, if I did not wish a very happy 247th birthday to my Marine Corps colleagues. So Simplify to my Jarhead friends. And then tomorrow is Veterans Day. And on behalf of the Scale Corporation, I would just like to say thank you so much for all the veterans out there, for your service and sacrifice. We salute you. So thanks again to everyone. We are signing off here from Scale headquarters in San Francisco. Be good, everyone.